I'd like to talk to you about domestication, and in particular, the way that I believe that the domestication of small-seeded annuals may have occurred. One point I want to make is that domestication is not simply a behavioral change, such as putting a giraffe in a pen. Domestication is a genetic change, and thus what you have in the process of domestication is a change in the gene pool of a population. And a changed genotype can be reflected in a change in the phenotype in the morphology. And the phenotype is something that an archaeologist can see. We've proposed many theories on how or why the domestication process occurred, but we have to turn to archaeology for all of our answers or hypotheses, since nearly all domestication occurred in prehistoric times before written records. Today I'll talk about the domestication of small-seeded plants. I'll start by talking about what and when is a domesticated plant versus what is a wild plant versus what is a weed. And I'd like to also talk about how did domestication come about, and especially when and where did domestication come about in Eastern North America. First of all, a wild plant can be differentiated from a weed and a domesticated plant because wild plants do not like disturbed habitats. And by disturbed habitat, I mean that a place where somebody has dug up the ground, like in a garden. And that's why gardeners who manage to grow something like this wild lady slipper are so proud of themselves, because they're growing a plant that does not want to grow in a garden or a disturbed habitat, and they're successfully growing it. Weedy plants and domesticates, on the other hand, like to grow in disturbed habitats. Here's my driveway, and you can see weedy wood sorrel. I didn't need to plant or even water to get these weeds. Now I can talk about the ways in which weeds differ from domesticates. One of the ways in which they differ is that weeds are very good at reseeding without any help from humans. Here with little barley, notice the brittle rachis or stem. And when each seed is ripe, the next piece of the rachis breaks off and the seed falls to the ground with the awns up. And then when the wind hits the awns, the seed can actually plant itself. Whereas domesticates have some kind of reduced seed dispersal ability, or not always, but oftentimes. For example, the ears of maize are covered in this husk. And although if this fell to the ground, you could get a clump of maize, it would not be very successful. Some domesticated plants no longer or rarely produce seeds at all. For example, bananas and sweet potatoes. These plants have become dependent on humans. Another way in which weeds differ from domesticates is that weed seeds may have dormancy, whereas domesticate seeds definitely lack dormancy. What is dormancy? Well, it's the ability of the seed to lie in the ground for many years, or just several years, but not germinate. So perhaps you've kept a garden, and one year you kept every single weed out of your garden, saying to yourself, next year I'm not going to have any weeds in my garden. Next year rolls around, and your garden is full of weeds. Where did they come from? Well, those weed seeds could have been 10 years old, 20 years old, maybe 50 years old. Whereas domesticates either come up the year that you plant them, or they're not coming up. The seed is bad. So you don't have to say to your husband, Bill, I want some sweet corn in 3 years. Let's plant it now. No, because you plant domesticates, and the year that you plant them, they come up. Now, how does this translate into something that an archaeologist can discover in the archaeological record? Well, one is that weed seeds might have dormancy because they have thick seed coats like you see here. So here's a very thick seed coat here. Down here, this is just the glue holding the seed onto the scanning electron microscope stage. Whereas over here, look at the thickness of the seed coat. It looks like paper thin compared to this one over here. So a seed that lacks dormancy may have a very thin seed coat, and a seed with dormancy may have very thick seed coat. And we paleoethnobotanists think that the seeds I'm showing you here, which both came from the same pit at a site in southwestern Ohio, we think that these are actually the same species, but simply the domesticate form on the right and the weed on the left. So you might also ask, why do these seeds look so different? Well, it turns out that chenopodium seeds, in chenopodium seeds, the embryo develops after the seed coat develops. So on the left, the thick seed coat constricted the embryo and gave the seed what we call a biconvex shape. Whereas on the right, the seed coat did not restrict the shape of the embryo, and we end up with a truncate margin seed. Another way in which weeds and domesticates differ is that ripening is staggered in weed seeds, and it can be staggered not only between plants, but on the same plant, versus in domesticates, ripening is oftentimes simultaneous. This is why when you're growing sweet corn, you need to plant another crop about every 2 weeks if you want to keep having sweet corn to eat. Weeds also tend to have high genetic variability, which translates also into high physical variability, whereas domesticates usually have reduced genetic variability and therefore reduced physical variability. So for example, on the left, you can see two current weedy plants and different heights. In the hordeum down here, you can see different ripening. Some are still green. The tips are ripe already. Whereas over here in the two domesticated plants shown in the pictures, not only are they all ripe at the same time, but look at the maize. All the ears are at the same height, and so they've been bred to be harvested by machines. Another characteristic that differs domesticates from weeds is that domesticates often have a reduction of protective devices. And these protective devices can take a number of forms. In the case of little barley, weedy little barley has these tight, inedible husks that are very difficult to remove. Whereas archaeologically, we find naked little barley seeds all the time, a sign that it possibly was domesticated. Or it might be toxins. So these wild squash here on the left are very bitter in taste, whereas domesticated squash, we eat the flesh. So the cucurbitacins have gotten less toxic tasting or bad tasting. That's also why you have to take care of your garden. Weed plants are very good at protecting themselves from the most common herbivores, which are insects. And they produce toxins, which for humans can also then become medicines. Once you take away those toxins or protective devices, you as a human then need to take over that job that the plant formerly provided. So you need to weed it or pick off the insects and help that plant survive. In a domesticate, the desired part often becomes enlarged through time, whether that's something like a leaf, as you see in cabbage, or whether that's a seed like you see in sunflower seeds. So how can we tell that a seed that we found in an archaeological site was from a weed or a domesticate? Well, there are a couple of archaeological correlates. One is that through time, the seed size may become bigger. And I want to point out that to look at domestication in the archaeological record, you need a sequence. You need to see seeds through time or whatever roots that you're looking at. You need to see the sequence of change, the morphological change through time. The seed coat may become thinner. So remember, weed seeds might have dormancy and domesticates definitely don't have dormancy. So the domesticated seed coats might be thinner than the weedy seed coats. You might see a change in seed dispersal ability, and this is certainly something that paleoethnobotanists see in Europe when they look at the origin of domesticated barleys and wheats. They see a change in whether the seeds remain stuck to the stem or fall off the stem. And finally, kind of an ancillary correlation is that you might find the plant being grown or you might find the seed at archaeological sites outside of its range where the plant did not grow naturally. So, how could domestication have come about? And why during the Archaic period, when people in eastern North America were somewhat mobile and not settled year-round in one place? So let's think about how domestication could have come about without people realizing that they were in the process of domesticating things. It came about from people being people and weeds being weeds. So think about it. If people collect edible ripe seeds from a stand or population of plants, you do that just once, you are selecting a small portion of the gene pool. Instead of getting this entire bell-shaped curve of not ripe yet, now we're ripe, now we're past ripe, you're getting only those that are ripe right now. So you have reduced the gene pool by getting plants that ripen at the same time. And if you select only those plants that have not already been good at dispersing their seed, that hung onto their seeds, you have also reduced the gene pool to just those that kept their seeds, that didn't have rachises that were brittle. And if you collect from that stand only once, you're unconsciously creating a founder effect. You're selecting only a part of the gene pool. You've selected only those plants that are ripe at the same time. You've selected only those plants that have not already been good at dispersing their seeds, that hung on to them. Now, if you ate those seeds, domestication is not going to occur. But if you save those seeds and plant them, and particularly if you plant them somewhere else with the intent to harvest them later, you have created the founder effect. Only part of the gene pool is now reproducing, and because you've taken them away from that original population, you being a mobile archaic person, those plants are now unable to cross back with the rest of the original gene pool, which would increase the uniformity. Remember, weeds have a greater genetic variability, and eventually domesticates have less genetic variability and more uniformity. And of course, what plays a role in this is how are the plants normally pollinated? Are they self-pollinated, wind-pollinated, insect-pollinated? That could play a role in whether or not what you've taken away could cross back with the weedy population from which you originally collected. And also, how do seeds move could affect that. Thus, people who move around a bit, such as the archaic people, are in one sense better able to domesticate plants because they take the seeds away from the local weeds and plant them elsewhere, allowing potentially no back crossing with the weeds. Now, if you harvest the seeds that you had planted, again, you may be unconsciously reinforcing several domesticated characteristics. If you harvest only once, if you collect seeds only from those plants that had germinated in that year, that first year after you planted them, you are collecting only seeds that lack dormancy. And again, you're collecting seeds that did not disperse themselves very well. And you're again collecting only seeds that are ripe at the same time, that don't have that variability in ripening times. Here's an interesting thought, that when you're taking away these characteristics, this part of the gene pool from the original stand of weeds, that is seeds that lack dormancy, seeds that were not good at dispersing themselves, you are not only potentially eventually ending up with plants that are more domesticated in character, but you're creating weedier weeds back at the original stand. What actions of humans lead toward larger seeds? Eventually, people may start to select bigger seeds to plant, or save seeds from the best fruit and plant those. We have to ask, are larger seeded annuals potentially contributing more seeds to the gatherer? It seems likely that seed size evolves as part of a spectrum of life history traits, including plant size, plant longevity, and juvenile survival rate, as well as time to reproduction. So a larger seed like this, among other seeds, when that lands in the ground, it might have an advantage in growth during the first week of life, and therefore that a little seedling will shoot up and shade out the others and become the plant that produces, and might have more stems on it, and therefore producing more seeds and contributing more to the seeds that you have when you harvest. It may better be able to withstand stress such as drought and competition. Here, for example, the archaeological record from the lower Illinois River Valley in west central Illinois shows the increasing size in some weed seeds through time in this one area. The red line and above are thought to represent domesticated plants. Domestication occurred multiple times in many different places around the world. Domestication was a process. Women likely were important in this process. Domestication originally was an unconscious process. It happened because of the characteristics of humans and the characteristics of weeds and how the two interact. Other down-the-road effects reinforce domesticity. For example, one reason that domesticated seeds tend to lack dormancy is that they have thinner seed coats. So that when people process seeds with thinner seed coats, such as grinding them or cooking them, those with the thinner seed coats will be easier to grind or process, whereas those with thick seed coats might not be digested. They might pass entirely through your gastrointestinal tract and come out the other end. So those with thin seed coats might be better digested.